take a moment and think about this. The water you drank this morning might be billions of years old. The same molecules could have once floated inside ancient oceans, passed through dinosaurs, or drifted through space long before Earth even existed. Water feels ordinary because it's everywhere. Rivers, clouds, oceans, even inside our own bodies. But when you stop and ask a simple question, where did all this water actually come from? The answer becomes surprisingly fascinating. Today we're diving into one of the biggest mysteries about our planet, how Earth got its water in the first place, right here on History of Simple Things. When Earth first formed about 4.5 billion years ago, it looked nothing like the blue planet we know today. Instead of oceans and clouds, the surface was an extremely hot, violent place, filled with molten rock and constant asteroid impacts. Temperatures were so high that liquid water couldn't even exist. During this early stage, known as the Hadean Eon, Earth was essentially a giant ball of magma. Any water molecules that might have been present would have immediately evaporated into space. This means the oceans we see today were not there from the beginning. So if early Earth started out dry and scorching, the big question becomes, how did water eventually appear in such massive amounts? One major theory suggests that some water was already present in the materials that formed Earth. The young planet formed from dust, rock, and minerals that clumped together inside the early solar system. Some of these minerals contained hydrogen and oxygen locked within their chemical structure. As Earth grew larger and hotter, volcanic activity became extremely intense. Massive eruptions released gases trapped deep within the planet. Among those gases were water vapor, carbon dioxide, and nitrogen. Over millions of years, enormous amounts of water vapor escaped into the atmosphere through volcanic outgassing. Eventually, as Earth cooled enough, this vapor condensed into clouds and began falling as rain. And this wasn't a gentle drizzle. Scientists believe it may have rained continuously for thousands, possibly millions of years. That relentless rainfall gradually filled low areas of the planet's surface, forming the very first oceans. While volcanic outgassing likely played a major role, it may not tell the whole story. Many scientists believe Earth also received extra water from space. In the early solar system, leftover debris constantly collided with young planets. Some of these objects were asteroids rich in water-containing minerals. Others were icy bodies similar to comets. When these space rocks slammed into Earth, they brought additional water with them. Over time, repeated impacts could have delivered enormous amounts of water to the planet's surface. For a long time, scientists thought comets were the main source of this cosmic water. But more recent research suggests that certain types of asteroids, especially carbon-rich ones, may have been even more important contributors. Their chemical fingerprints match the composition of Earth's ocean water more closely than many comets do. This idea means that some of the water in your glass today might have originated from ancient asteroids that crashed into Earth billions of years ago. To figure out where Earth's water came from, scientists examined something called the deuterium-to-hydrogen ratio, often shortened to the DH ratio. Deuterium is a heavier form of hydrogen, sometimes called heavy hydrogen. Water molecules contain hydrogen atoms, and by comparing how much deuterium appears in different water samples, researchers can trace possible origins. Think of it like a chemical fingerprint. When scientists compare Earth's oceans with water found in comets and asteroids, interesting patterns appear. Many comets have a much higher DH ratio than Earth's oceans, which suggests they probably weren't the main source of our water. However, certain asteroids, especially carbonaceous chondrites, contain water with a pH ratio very similar to Earth's oceans. This strengthens the idea that asteroid impacts delivered a significant portion of our planet's water. Even after billions of years, not all of Earth's water is on the surface. Scientists believe enormous amounts may still be hidden deep within the planet's mantle. Minerals located hundreds of kilometers below the surface can trap water molecules inside their crystal structures. One mineral in particular, called ringwoodite, has been found to contain significant amounts of water. In fact, some researchers estimate that the mantle could store as much water as several oceans combined, just locked inside rocks instead of forming seas and rivers. This hidden reservoir suggests Earth's water cycle may extend much deeper than we once thought. Water doesn't just circulate between oceans, clouds, and rivers. It may also move slowly between the surface and the deep interior of the planet over geological timescales. Water likely existed on several early planets, but not all of them managed to keep it. Scientists believe Mars once had rivers and lakes, and Venus may have had oceans long ago. However, Earth's stronger gravity and stable atmosphere helped trap water vapor and maintain conditions where liquid water could survive. Mars lost much of its atmosphere, letting water escape into space, while Venus became extremely hot due to a runaway greenhouse effect. Earth happened to stay in the right balance, allowing its oceans to remain for billions of years. So where did Earth's water come from? The most likely answer is that it came from several sources working together. Some water probably came from minerals present when the planet first formed. Huge volcanic eruptions released water vapor into the early atmosphere, which later condensed into rain. And on top of that, asteroid impacts may have delivered additional water from space. Together, these processes slowly transformed a fiery, lifeless world into the blue planet we know today. And the next time you take a sip of water, it's worth remembering something incredible. Those tiny molecules may have traveled through volcanoes, asteroids, ancient oceans, and even deep underground rocks during a journey that started billions of years ago. In a way, every glass of water carries a piece of the universe's history. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.